So this is my second lab for Physics 2, which is the lines of charge. So to introduce, the purpose of this lab was to understand the properties of charge and how they interact with their surroundings using a more sophisticated model in comparison to the previous lab. So to give a preview for the results, the tape had a charge of negative 3.02 times 10 to the negative 8 coulombs, which means that there was actually an increase of charge from the charge calculated in lab 1. The main fundamental physics principle we used was Coulomb's law, which is a law that quantifies a force exerted by a charged point, so the source, upon another charged point, which is the surrounding. And I used this equation, and it can be better interpreted through this diagram. And then also we use the fact that the E field is this constant times the one charge divided by the magnitude of the R vector squared times R hat. So the method of the experiment was the same as the previous one, which was to make a U-tape, and then prove that it was negatively charged. Then repeat the previous step. So we obtained 2 tapes, put one tape on top of the other, like stacking books, and then you slowly lift the bottom tape until there's some repelling from the top tape. So until it floats. And then we record the distance between the tapes. So the assumptions I made for this model was that the tapes repel because they're negatively charged. They will repel with equal magnitude and charges distributed uniformly throughout the tape. Plus, forces due to air resistance can be ignored. So this was the experimental data I obtained. To cut it short, it was basically the same as the previous lab. And again, for the computational model, I assumed that the charge calculated was correct. So that means that the tape charge was negative 9.41 times 10 to the negative 9 coulombs, and that the magnitude of the electric force is 1.28 times 10 to the negative 3 newtons. So for the computational model, again, I did assume that the charge calculator from lab 1 is correct, and that the tapes are made up of an even distribution of point charges. And I kind of use the fact that it's an infinitesimal amount of point charges because it is a 3D object, not a one-dimensional scenario. And other forces acting on the tapes are negligible, like air resistance. So this is the code for the observed values that I used. This was to calculate the mass, and this was to calculate the charge. Then this is a code for the electric fields. It was already given to me, and I just simply edited it to give the electric field. Then I used the code for graphs and visuals. I think I couldn't edit this one, but yeah. And then for N, I used 45 just because I felt like this number was a right number as I viewed the results, like the diagram. And then I used this to calculate the electric field at the top arrow and the force at the top arrow, so like their magnitude. And then this is a last piece of code, which is the net electric force and the gravitational force. So the results mentioned that the magnitude of the electric force is 3.97 approximately times 10 to the negative 4. And the magnitude of the gravitational force is 1.27 times 10 to the negative 3. The change in the electric field is 31.2%. And the distributed charge across the tape is negative 3.02 times 10 to the negative 8 coulombs. And this was a diagram I obtained. So to reflect, what if you had modeled each of your tapes as a single point charge like in the previous lab? Well, the line point charges meant that the charge increased by 321%. And we are assuming that the line point charges are a better model considering real world applications, which can also be answered through the following question, which is why do these estimates differ? And I believe that it's because line charge model uses less drastic assumptions and behaves more like charges interacting with surroundings in the real world. So it's a better approximation of this. Thank you.